Okay, in this video we're going to work on solving equations with variables on both sides. So you'll see our problem has an x on both sides of the equation. So the first thing that you need to do is try to get them on the same side. So what I do is I kind of underline both of them. And I think I'd like to have my x be positive in the long run because I have to make it positive anyway. So I think that I want to take this negative 7x and I want to add it to this side because then I'll be over the positive side and then I'll just have to move the 15. So if I add 7x over here and I add 7x over here to keep the balance, then I'm going to get 0 here. And negative 2 plus 7 is 5x. And I've done nothing with this yet, so that's your 15. And you have a plus because it's now positive 5x. So now I really need to get rid of this because I need to get x by itself. And you have to get everything away from it first. So I'm going to take and subtract 15 over here. Subtract 15 over here. This becomes a 0, so I still have 5x over here. This will be negative 15, and then I can divide by 5. Divide by 5. So my x is going to be a negative 3 because a negative and a positive make a negative. So to check my answer, what I need to do is I need to plug this negative 3 back in for x. So I take 15 minus 2 times negative 3 is equal to negative 7 times negative 3. So we have to double check that this is a true statement. Well, I know that a negative times a negative is a positive, so that's 21. And then I know this negative and this negative times each other will make a positive, so I've got a plus 6 and I still have my 15. And 15 plus 6 is 21. So that does make a true statement, so this is a correct answer. So that is one way you're able to do that. I know you may find another, but your solution should be negative 3 in the long run. I have another one to put on here for us to try, just to see if you understand it. It's going to be more complicated, so bear with me. We're going to have negative 2 times the quantity x minus 5, end of the quantity, equals 6 times the quantity 2 minus a half x. Again, you're going to notice that we have the x's on both sides of the equation, but it looks way more complicated. So we need to distribute. The distributive property is when you have a number squished up next to a parentheses that has more than one thing in it. It's actually multiplication even if it only has one thing in it. So I'm multiplying and multiplying. And I'm going to multiply and multiply. And then I'll solve it from there. It'll look similar to the first problem. So your negative 2x and x make negative 2x. Your negative 2x and negative 5 make a positive 10. This equals your 6 and your 2 is 12. And your 6 and a negative half is going to be a negative, and half of 6 is 3x. So now we're going to do the same thing. I'm going to underline my x's because I want them together. But again, I want them positive. So if I add 3 over here, I'll get over the hump of being negative here. So I think I'm going to add 3x and add 3x. So this becomes just 12 over here. And this will be a negative 2x plus 3x makes just x. Plus my 10, I didn't do anything with that yet. So then I want to subtract my 10, x is by itself, and I should get 2. Now I want to double check that answer before I go any further. So I can replug 2 into every x up here. So 2 times 2 minus 5 equals 6 times 2 minus a half times 2. So let's try this out. What's 2 minus 5? Negative 3 times negative 2, which is 6. Over here, I go into the very inside parentheses first, and I have half of 2. Half of 2 is 1. So I've got 2 minus 1, which is 1. and I still have that then, times my 6, which in the long run will be 6 is equal to 6. So that is my final answer. So you can always solve the problem and then check it by putting that number back in for every x. And if you come up with a solution that is a true statement, you have figured out the answer or the solution to that equation. This might have been a complicated one. You might want to re-watch parts of it, or you may want to try one on your own. If you need to come back to this, you may. Good luck.